Dear students, welcome to the second lecture of trigonometry. In this, I'll teach you how to solve exercise 8.1. If you haven't watched lecture 1 of trigonometry, then must watch it for understanding the basic concept of trigonometry. Its link is given in the description. Okay, so let's begin. In the first lecture, we have already understood all the trigonometric ratios and their formulas. So, in exercise 8.1, we have to apply all those formulas and find the values of the trigonometric ratios in all the questions. But there are two types of questions. The first type is when two sides of a right angle triangle are given and we have to find the trigonometric ratios. And in the second type of question, one trigonometric ratio is given and we have to find the other trigonometric ratios. So let's begin with the type 1 questions. There are two questions in this exercise of type 1. Question 1 and question 2. So let's solve question 1. In triangle ABC, right angled at B, AB is equal to 24 cm, BC is equal to 7 cm. Determine sin A, cos A, sin C and cos C. So we have drawn the figure. In this, as you can see that two sides of this right angled triangle are given. And we have to find the trigonometric ratios sin A, cos A, sin C and cos C. So the first step is to find the remaining third side. Always remember this. Whenever two sides of a right angle triangle are given, we have to find the remaining third side. Why? Because we have to find sin A. Now what is the formula of sin A? Sin A is equal to side opposite to angle A upon hypotenuse. So side opposite to angle A is BC and the hypotenuse is AC. Hypotenuse is the side opposite to the right angle. So we have to find the hypotenuse by using Pythagoras Theorem. According to Pythagoras Theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides of a right angle triangle. Okay, so by Pythagoras Theorem, AC square is equal to AB square plus BC square. Now putting the values of AB and BC in this formula, we can find the value of AC. Okay, so substituting the values, we get AC square is equal to 625. Now we have to find the value of AC. So AC is equal to under root of 625 and 625 is the perfect square of 25. So AC is equal to 25 centimeter. So now we have find the length of the hypotenuse of this triangle. Now we can easily calculate the values of sin A, cos A, sin C and cos C. So first is sin A. Sin A is equal to side opposite to angle A, that is BC. Opposite to angle A is BC and hypotenuse is AC. So BC upon AC and this will be equal to BC is 7 cm upon AC is 25 cm. So this is the value of sin A. Sin A is equal to 7 by 25. Let's find cos A. Cos A is side adjacent to angle A upon hypotenuse. So the side adjacent to angle A, that means the side next to angle A is AB and the hypotenuse is AC. Substituting the values, AB is 24 cm upon AC is 25 cm. So this is the value of cos A. Now as we have find the values of sin A and cos A, we can also find the values of sin C and cos C. So sin C will be equal to side opposite to angle C upon hypotenuse. So let's see. This is angle C and the side opposite to angle C is AB. So side opposite to angle C upon hypotenuse. AB is 24 upon hypotenuse is 25. Now cos C is equal to side adjacent to angle C upon hypotenuse. So the side adjacent to angle C is this. Always remember adjacent means next to. So cos C is equal to BC upon hypotenuse, that is AC. BC is 7 upon 25. Okay, so we have found the values of all the trigonometric ratios in the question. What we have to do? We just have to find the length of the unknown side using Pythagoras Theorem, which says AC square, that is hypotenuse square, is equal to the sum of squares of other two sides. If two sides are known, then we can easily find the length of third side using Pythagoras Theorem, so learn it by heart. Now question 2. The same procedure you have to apply to question 2. What does question 2 says? In figure 8.13, find tan P minus cot R. So as you can see in the figure, the length of two sides is given and the third side is unknown. So using Pythagoras Theorem, the same formula, we can find the length of the third side QR. Here the Pythagoras Theorem will be PR square, PR is the hypotenuse, since PR square is equal to PQ square plus QR square. So QR can be calculated. After calculating the length of QR, we will find the value of tan P and the value of cot R using the formulas and then substitute them in this expression, that is tan P minus cot R, and that's all. Okay, so solve out question number 2. If you have any problem, then do comment it and I'll upload a video on this question as well. For question number 3, 4, 5, 7 and 8, watch lecture 3 of trigonometry. Its link is also given in the description. That's all for today. Do like, share my video and subscribe my channel for further lectures of trigonometry and the rest of the chapters of class 10th.